Reduction of emissions in power production, LowNOx technology. My name is Merja Mäkelä and I come from Southeastern Finland University of Applied Sciences. You are very welcome to participate in this learning session. In my presentation, I have firstly a small introduction. Next, I come to the main topic, LowNOx combustion technology, and finally, I have my conclusions. Firstly, this introduction. The Directive 2010/75 of the European Union for industrial emissions gives the general framework for industrial emissions. This directive is applied to several industrial sectors, including energy production. There is another important and interesting document called Best Available Techniques reference document for large combustion plants. It has been updated recently, and this document gives the general techniques to prevent and reduce emissions and consumption. We get toxic and harmful emissions from combusting power plants. We always get carbon dioxide from combustion. In addition, we get other emissions. Sorry. In this presentation, I have a focus on nitrogen oxides. In the figure, you see a combusting power plant. Fuel, in this case coal, is taken to the furnace. There it's burning. It produces heat, but it also makes flue gases with harmful and toxic emissions. This heat boils water in the water circulation, and it makes steam, high pressure steam, which is taken to the steam turbine, connected to the generator, and in that way we get electricity. The steam condenses, and we get water back to the circulation. This condensing may be utilized, that heat may be utilized for district heating or for industries. Basically, there are three principles how to reduce emissions in power production. We may use cleaner fuels and processes, and this makes the basis for the reduction. We may utilize improved combustion technology, and this utilizes primary methods, LowNOx technology, for example. We may treat flue gases, and these methods are called secondary methods. Next, I come to the main topic, LowNOx combustion technology. There are several basic requirements for LowNOx combustion. We should be able to ensure operational safety. The power plant operation should be reliable. We should be able to avoid corrosion, for example. We should have minimal adverse impacts on operating parameters when using that technology. The energy efficiency should be as high as possible. We should be able to burn a wide range of fuels. The combustion should be complete, otherwise we get carbon monoxide. We should produce low emissions, as low as possible. These methods should have a minimal adverse impacts on flue gas cleaning. When using LowNOx combustion, we should keep the maintenance costs as low as possible. We get nitrogen oxides both from air and from fuels. That combustion air contains a lot of nitrogen, about 78%, and 21% oxygen. On the other hand, we get nitrogen from fuels. All those methods aiming at the reduction of nitrogen oxides in combustion are called LowNOx combustion technologies. There are also so-called DeNOx technologies. They are aiming at cleaning and removing nitrogen oxides emissions when they are produced. In certain conditions, we get more nitrogen monoxide. When we keep the combustion temperatures low, we get little nitrogen monoxide production in the combustion. Temperatures less than 1400 Celsius degrees results in less nitrogen monoxide. Temperatures higher than 1600 degrees results in more nitrogen monoxide emissions in the combustion. Principally, the amount of nitrogen in fuels compared to air is rather small, but this fuel nitrogen is very reactive. We could state that fuels containing plenty of nitrogen mostly produce more nitrogen monoxide emissions. Those nitrogen reactions in the combustion, they are rather complicated, numerous, but well known by the scientists. In this table, you see some common fuels and their nitrogen contents. Those figures are given as a weight percentage in dry fuels. You see that municipal waste, for example, natural gas and coal have rather high nitrogen content percentages. In this figure, you see the main methods, main modifications for the reduction of nitrogen oxide emissions in combustion. The first method uses low excess air. The second method, it's called air staging. It can be applied to the furnace, or it can be applied to the LowNOx burners. The third method uses flue gas recirculation, and it can be used both in the furnace and in LowNOx burners. The fourth method uses reduced air preheating, and the fifth method, fuel staging, it can be also applied in the furnace itself or in LowNOx burners. I come to some more details in the next slides. First, this air staging. When we start here on the bottom, we feed fuel, we feed air in the main combustion zone. And we keep the stoichiometric ratio SR rather small, mostly below 1. And then it means that we have a less combustion air in this main combustion zone, and this results in less nitrogen monoxide. Then later, in the secondary burnout zone, we take excessive air there, and this is called overfire air. This completes the combustion, and this everything results in less nitrogen oxides. This air staging principle can be utilized also in LowNOx burners. When we look at the figure on the right side, in the middle we take fuel and air in, and then in this phase we have less combustion air in this primary zone, and this makes hydrocarbon radicals which partly remove produced nitrogen oxides and reduce the production of nitrogen monoxide. Then in outer parts of the flame, there we have excessive air from the secondary air feed and tertiary air feed, and this completes the combustion, and we have enough air, and this everything results in less nitrogen oxides in this kind of a combustion. Flue gas recirculation can be used to reduce nitrogen oxides. In this example, we have coal as a fuel. It's taken to the furnace together with oxygen. We get oxygen from this air separation unit, and it means that nitrogen is removed from that combustion air. We take some recirculation of flue gases, and this comes together with that oxygen to the combustion. This makes lower temperatures there in the and lower oxygen content in the combustion, and this does not bring that much nitrogen oxides. A disadvantage is the fact that this kind of recirculation reduces somewhat the energy efficiency. But this is rather widely used in power plants. We may also use fuel staging in combustion, and it looks like this. In the primary zone, the main fuel is combusted using excessive air, and it means that nitrogen monoxide is produced. In the secondary zone, we feed an additional fuel, and we choose the fuel in that way that it's possible to reduce nitrogen monoxide using these hydrocarbon radicals of that phase. In this zone, we have less air. The combustion is completed in the tertiary zone, and there we have enough air, and the stoichiometric ratio is more than 1. This fuel staging results in the reduction of total nitrogen oxides. Finally, I come to my conclusions. Harmful and toxic emissions coming from combustion can be reduced using clean fuels, advanced combustion methods, and cleaning methods. In these presentations, I have discussed the reduction of nitrogen emissions using LowNOx technologies. The main principles in LowNOx technologies are air and fuel staging, and also the flue gas recirculation, and these methods are called primary reduction methods of nitrogen oxides. Thank you for your attention. Have a nice day. Goodbye.